everyone. Today I'm going to talk about accelerated internet. How many of you remember, loading an internet page and seeing the pictures, you know, refreshing after a while? I mean, taking a long time. Right? It doesn't happen today, but it used to happen. It used to happen some time back, right? So there is a lot of change that internet has gone through, and I wanted to see if I can highlight some of these things in my presentation today. Why and what changed and how things really materialize for us to see such a good experience of internet. Actually, there was a time in between where internet was on its knees and people said, okay, this is going to break down. So something saved it, and I'm going to try and highlight something out there. So let's understand internet. What is internet? I believe most of us understand, but let's understand a little bit more deeper. So it's basically a cloud, right? On one side we have a website provider, and on the other side we have the customer, or you, sitting and watching on your laptop, right? So that's pretty much how we understand internet. What happens in between is the real magic, right? So let's see. Generally, you will be hooked upon to one of your ISPs, like Verizon or somebody, right? So you will have a Verizon's network here, right, which you are connected to. And you, of course, have a very good bandwidth to your ISP, whatever is promised to you. Like Verizon gives like 20 megs, so you have that speed. However, when you're trying to reach the site, you are probably going through different networks, okay? So this could be, for example, L3 network. This could be in between some other network, right? And say that's AT&T. So your traffic is actually getting routed here through these networks. This is what is the challenge. Actually, if you see, most of the intermediate peer-to-peer handshaking people, in this case, say between AT&T and us, they keep their routers who really switch your traffic in a way that they really don't want to take your traffic, most probably. So the way the internet started buckling down was, these guys say, okay, if you want to use my router, it's going to probably cost you 20 more hops. So use something else. Because the routing algorithm that internet uses for the information flow is a BGP algorithm, which is Border Gateway Protocol algorithm, which just looks at what are my nearest hops. Say, for example, this was a site in Los Angeles, and say you were sitting in New York, right? Or say, for example, you're in Tampa, right? So to hop across, they will figure out how many hops I need to do. That's a simple Border Gateway Protocol that really works around to figure out how many hops. And what this value is actually physically put by AT&T. So AT&T is going to say, okay, I'm going to put 20. Actually, it might be just 3 hops away. And they're going to discourage your traffic or Verizon's traffic. So they can do that. So internet was really buckling down with all this. It was insecure and slow. The reason it was insecure is because of this, the silos of network. Like somebody can really, if this was your bank, somebody can really spoof the same IP in your local network near your ISP and act as if that was your bank, because that will be hit on first, and you will suddenly see a spoofed up page which really shows you your bank page, because you're just putting the IP that this guy is supposed to be going for right here. So there were a lot of insecurity which was coming across because of the way internet was designed. Now, back in '95, some of the MIT graduates from Thomas, British, and Danny, there were 3 people who came along together, and they were actually from a math department. They came up with an algorithm how to do this whole handshaking across the router and how you can really speed up the internet. They brainchild a system called Akamai. I don't know how many of you have heard about it, but Akamai is something which is really saving the internet a big time. Now, when they started off, this was like a college project, so they were given like 50,000 to really show up this particular project, whether that idea is going to be worth it. Somehow they reached into final 6, and they really lost. They didn't really get the 50,000. But it really brought a lot of industry people when they saw it, like these are for the first 6 projects from MIT. The industry people jumped in and started providing enough funding to really take this off. So these 3 guys, 95 they spawned the idea, 98 they really got a business, a pilot approval. They did a pilot within the MIT itself. They really saw how acceleration can be implemented with that technology. And 99 they really established Akamai. And within like few years, like 3-4 years, they were running into billions. And that's really a shoot of a company that you wouldn't have seen in stocks that any other company would have taken. The first thing that happened for them was after they formed it, it was ESPN who was like getting crashed with their site. ESPN is generally very good at their website. So they were crashing around and they said, okay, let's take help from Akamai. So they took help from Akamai and asked them, okay, can you support like 1,000 hits per second kind of traffic? So these guys said, okay, we are going to step in. We are going to push our technology and see whether we can support this. They were able to support much more than 1,000, like almost 3,000 hits per second. The same very day, there was a Star Wars trailer released, and Apple had exclusive rights on it. Okay, so Jobs saw this, and he was trying to put this trailer exclusively through Apple's site, and somehow his site was crashing totally. But there was another team, entertainment media, who didn't have the rights, but by mistake, it basically took help from Akamai and said, okay, release this trailer for us. And Akamai really distributed. What Akamai did is it basically distributed on the edges. So they basically distribute the same content, the trailer, on the edges. Okay? So Akamai was able to distribute this trailer very well when Apple's site was crashing on that particular day. So media, everybody caught this attention. They realized where things are going, and Akamai got a very big push on what they can do, what are their abilities, and how they can really distribute content in a seamless way that people would be able to fetch it very easily. Today, every content that you see on internet uses some kind of Akamai servers, which are basically edge servers, duplicating content right close to your ISP, into your ISP's network, by really improving the speed and security for you. So next time you look at internet, I hope you're going to look at it in a different manner. Thank you.